right? And how it is differ from the other one. Okay, so so last class actually, so we come up with the, what is that, like the mathematical proof, how we are going to use that, um, mathematically how we are proving, as well as the program wise we have proved that how it has been done. Okay, so I think I'm not sure whether you get a chance to go through that, the slides and the code which I shared. Okay, so anyways, just quickly we'll have that, then I'll jump into the simple demo and the major the steps what we need to be carry forward when you're doing the linear regression. This is actually normally for any kind of the model implementation. That's very important. Okay, so just to recap that one, and then finally like I'll jump into that, what is that, our demo point of view. Okay, so the last class we said like linear regression going to be single variant, single simple linear regression, as well as the multi-linear regression. Okay, so the some simple one linear regression is going to be just we are going to have one-to-one. For example, if I have the independent variable going to be a number of independent variable along with the multiple factors. Basically, the multiple factors will deciding the dependent variable, the final outcome. So that is nothing but a multilinear regression. So the equation you can say like y is equal to b0, b1 x1, and b1 b2 x2, and so on. So what we can do, like, so we are going to bring up the individual the factors, the individual features going to be, for example, in my program, so in my code, the given data set, so I can take it up, the fixed acidity and volatile acidity and the citric acidity and so on. All these factor going to decide the quality of my the wine. So this is a simple example how they are related. Okay, so the simple linear, it's nothing but is you are going to be a dependent variable and your independent variable and intercept. So independent variable, for example, like the as we discussed last class, I think the TV purchase per advertising data set. So there's going to be a TV, newspaper, and radio, I guess. Okay, so there are the other variables. So you can take any one of the variable and you can find out like the advertising, like which more gives the more impact when we are when we are giving advertisement through the um, through any other media. It could be a TV, or it could be a radio, or it could be a newspaper. So if you're going to take a single variable, then going to be a normal linear regression, and most of the time it's going to be a multiple linear regression. Okay, in that case we are going to have n number of the variables for our analysis. Okay, that's very important. That's what actually last week we have just, I want to highlight that due to that the system issues we're not able to proceed. Okay, so and these and all, like so manually I've created like how um, the relationship, the positive relationship and negative relationship. Okay, so whenever you're doing your analysis, make sure that your analysis is going to be a positive relationship. Okay, okay, so because then only you can get the proper the curve to fit the regression lines. That's very important. Okay, because sometime when you're choosing the different variable, like independent variable, dependent variable, you have to be very clear about that. Okay, the objective of implementation is very important to decide what are the features going to be a independent variable, and always going to be just one variable going to be your dependent variable. That's very important. Okay, and make sure that the individual variable relationship should be linear. Otherwise, like, definitely will not get any the proper linear curve. And I've explained this one. So when you fit that regression line, and this is going to be estimated one through your program, and actual is going to be so it might be here, right? In the between, if you have a spaces, okay, that might be some what is that? It might be some value. So it's going to be an error. So basically, we want to reduce the error to fix the proper um, regression line. So that's what actually I have mentioned. AIM is used to reduce the error. It means reduce the distance between the predicted value and actual value. Then only you can say your model is good. So for this, what you can do, for example, if you're fixing like multiple linear regression, you might have a n number of parameters. I'll show that demo. Don't worry. Okay. So if you have a n number of variables, what will happen? Each and every variable may or may not be impact the different variable. So because of that, your error might be huge. So selecting that features is also very important. Okay, and this is a separate topic like for feature selection and all. But since we have a time constraint, we're not able to go deeper in that. Okay, but the same way, if you're selecting proper features, like what are the features you want to select? For example, here I have, if I am selecting n number of options here, so only the fixed acidity and volatile and citric, only the all the three features impacting that my quality of the wine, then I should consider only these three. Okay, I might have a number of columns, a number of features, but all the things not required to justify my quality. That's very important. Okay, we'll see some classic example soon. So that's very important, right? And already I'll have shared this one. And same way, after you put up that the actuals, so probably I think last two classes we have seen the output actual and estimated, right? So probably I'll pull out that the code so you can understand. So once you're comfortable with the basic what is that, how we are going to set up that, how we are going to apply your model, then it will be easy to for rest of the algorithms. That's a very simple, straightforward. Only the statement. First of all, we need to load the data and do the all the initial analysis, and we have to do that exploratory data analysis. After that, automatically. So so compare this one. So here I have 25.2 and it's a 23.4, and you can compare here what exactly is actual estimated one actual here. Okay, so we have some distance between the 2 points. So how we can justify whether this is a good prediction or not, right? So we have a simple statement like accuracy, right? So regression score is a simple statement to find out the simple accuracy by using the simple statement regressor dot score. Because actually I think already we have discussed multiple times like how to apply the what is that regression equation on after splitting your text at train and text. Okay, so I think multiple times we have discussed about this one. I don't repeat again and again. Okay, so here the simple statement, just a regress underscore, then I can get the value 0.54. This is nothing but the percentage is nothing but 54 percentage. 54% is nothing but what? Just a 50%. The model is fine. But anyway, it's really very low the percentage. But anyway, we'll consider actually we have tried the maximum because the given data set like that. Then only, that's the reason actually we are getting this. What is that? The 0.4550. And same way here, after you are applying the model, so we need to find out the root mean square error. Okay, root mean square error. So that's the reason actually here I clearly mentioned one of these slides and the steps. I think I don't discuss again this one, right? So we have tried to fit this line so that what we are doing actually we are making different changes. And see here, so if the value of the r square, that is nothing but your root mean square error should be less than or equal to 1. Okay, if it's equal to 1, and if it is going to be like, for example, always should be, if it is equal to 1 means we have a good relationship. Okay, and same way, if it is point 2 and look at this samples. If let's say forget about all the other points, so if you have the distance, automatically there is no proper relations between the two things, so that obviously the model is really bad. So we need to find out the regression line in somehow in different direction. So how it is going to be? 1 minute, let me pull up the uh, paintbrush, so it will be easy, because actually for this Google one, really we don't have the paintbrush. So okay, so right, right. So in the case, if I'm drawing some lines, it could be any line. Okay, not actually the straight line. So I need to figure out which is maximum. This is my predicted one, and this is my line, means definitely the distance between the two is more. If my actual and prediction, if nearing by this one, this line means, so I can choose the specific line is my, the specific line is going to be my linear equation. Properly I can decide. So if you find out the value of the R, definitely is equal to going to be a 0 or less than 1. Okay, near to that. If it is going to be more than values means, we look at here. The value is like the R is going somewhere and the data is going somewhere. Look at here. Actually, the time and is a predicted one. So 25, 1, 50, 12, 80, 20. So that there is no matching. So obviously, this model is very, very worst. So the same way, if you look at this one, so you can see such just 4. So really unrealistic, because I'm putting some curve here. The most of the data is away from that. So we cannot do anything because the given data point is just like that. Okay, look at here, 11 point and here the 13, and here I have 21 and this is 27. So the variations really, really vary. Okay, so that's the reason we are getting the maximum value. That is where accuracy is a 0.54. So model is really bad. So what we need to do, we need more data point to collect. Then only we can predict. Then only we can predict there are going to be a rain or not. The given data is not at all worth to do all the data point. The data what we are collected really not good enough to predict the what is that the weather predictions, really not impossible. So we need to collect more data point. So we need to request the more data point from customers saying that, hey, the given data is like it's really unpredictable, we're not able to proceed to that, so we need a proper data point. This is for a single simple linear, because I'm taking a one variable and I'm planning with that. So the same way what is this one? Oh, this is required. Okay, so same way, let me take this wine quality prediction. This is a multilinear example. So how many of you tried a simple linear things, guys? You have tried anything? Anyone? You guys have tried any, like at least you tried your own? Hello?
Students, you can respond to his question. Otherwise, even at least in the chat window, you can give away your answer.
Yeah. Guys, I'm not able to, because 37 people are there. Okay, so here actually I have the wine quality data set. So these are my column. Okay, so there are 12 columns are there, right? So as usual, like I'm going to check whether it's a null, and just I'm finding like all heat map and all the how it is really correlated with each other. So I think already we discussed this so many times, like all these points, right? So now the same way. So what I'm going to do, I'm going to select only the selected item for my regression, and what is that? Yeah, see here. So for this equality is going to be my independent variable, and the set of features going to be my what, like my the other features. That's going to be an independent variable. So what I'm doing, I'm selecting the fixed acidity, other data point, and all the data is like how many fields I'm selected: 1, 2, 3, 4, 5, 6, 7, 8. So out of 12, one is going to be independent, so that's going to be 11. And in the 11, I'm selecting only the 8 because the other rest of the things is not required for my analysis. So that I'm taking all these features. I would say this is a feature. So the features going to be my all going to be my independent variable to get the to get qualify the whether the given whether it's a quality or not. Okay. So the same way, just I'm applying. Forget about all this code line. I will share and just go through that. So anyway, like already we have discussed about that. Okay. So here I'm doing a split, random split, everything. Okay. And I'm applying my linear regression. So once I decided x is equal to features means all these features here I have some function. So all the collection going to be, yeah, going to be x as x, and all the only just a quality column is going to be my dependent variable. So I'm assigning those things, and as usual way I'm doing this random. Okay, just I'm printing all these values. So probably if you print statement, you can understand this. So how much you have printed. Print. Okay, this is a simple statement, not required. Just if you want to find out the how much like a split, right? So you can understand that. Okay. So today we'll quickly close this one and then jump into the other one. Just you run this, will get the value. Don't panic about this. Is actually all the test predicted values. So after passing my X test to this method, simple method, you don't bother about. That's what I mentioned. But mathematically, you want to understand what exactly the values, the predictor values. The predictor value is nothing but this value. Okay. So the predictor values is sometime if you have some value, so predictor value is going to be this one. Okay, for a given test data. But already you might have some values here like this. Okay, it could be anywhere in your chart. So for classic example, I can say here, right? Just simply like you can align this one. So all this data which is predicted one. No need to print any values, but just I'm telling. Okay, and here I'm predicting value 5, 5.6, 5, 5.2, 6, 5.7, and 5 value. See, look at here. Almost is really like we're close to that. Like previous example, what we have discussed. So here, the matching with one, 11, 13, 21, 27, 22, 25, and 20, 26. So there is a huge variation. You can understand that, right? So for example, here the since actually data is the given data set is like we have a huge data, and we have a properly data we collected, so that we got at least a minimal distance. And if you even look at say 5 is a 4.9. So nothing, not major difference, right? So even in the bar chart, you can predict that, the actual predicted. Easily you can find out. See, look at here. So we don't have any much difference, right? So almost look at this one and look at this one. So all those, everything's the same. So let me see what is the percentage of uh, the values. 1 minute. Score. Yeah, and even score is say actually I'm getting like probably like here I'm getting only the selected value, since how many rows are there? The rows almost, how many rows are there in this column? Size. What is the size? Yeah, I have 1599, almost 1600 rows are there. I think what are the data we are seeing is going to be like mostly um, here the data. I think the top 25 looks like a very closure. Okay, so probably if you look at that the entire touch, it may be different. That is the reason actually we are getting the percentage. What is that? Is a 34 percentage score. And again, this is also the performance of this system is really very poor. Okay, and here I have a mean square root is a 0.6. So based on my analysis and given data point here, okay, 0.6 is a good fit. Anyways, even though it's like, so there are some conditions. If it's going to be a 0.5 or if it is going to be a 1, perfect fit. And if it's going to be a 0.5 related to that, it should be like always. But in other example, we got like root mean square is going to be a 4. That's really worst, because the given data is not enough to do the analysis. That is the conclusion. Okay, so any questions here? And before jump into the next model, so these are the very main important steps, guys. So be clear about that. So if you go with any kind of evaluation, any kind of machine learning if you're going to apply anything, that's the main one. You need to import the required files and libraries. Yes, you can do that, right? Hope you understand. And in which actually is going to import all the libraries and import the CSV files. That's very, very important. And data set initial analysis, you're supposed to do the explore the data and the statistical analysis of the data set and do the exploratory data analysis. All the piece of work you are going to do in your set. And the same way you can do the univariant bivariant visualization graphs, so that you can understand how all the B features reach related each other. That's very, very important. And then the feature selection. Feature selection is nothing but the finding and designing the dependent and independent variables, like how we can select that. So probably what I will do, I'll try to make it like at least a 30-minute session probably later. So how to do this, if you do this feature selection, because we want to what we'll do usually like this. For example, if I have 1 minute, let me increase the size. Yeah, let me go with yeah, auto PG. Because drawing everything on the paint is really tedious. Yeah. See here, this is a simple data set. Okay, so to find out like this is actually we can use this specific data set for the other analysis as well. So if I want to find out that the specific MPG, right? So I can consider the cylinder, displacement, horsepower, weight, acceleration, model year, and origin and name. Okay, so if I want to decide the specific the parameter feature, right? If you're going to decide the specific feature, what I used to do, in first step, I will go select with the cylinder and MPG. So how it is performing. Then what I will do, I will go with the combination of a cylinder displacement and MPG value. I can predict that one. Okay, miles per gallon. What is that? MPG. It's like the units. Okay, and horsepower. So what I will do, I will find out whether all these three features will impact my MPG or not. Certainly, the name will not impact. Correct? It's not required, and sometime origin not required. So what I will do, I'm not going to select this two column very initial moment. I can exclude this specific the column for my analysis. So this is going to be nothing but what is that? So can hide this one, for example, saying, and model year. Even I don't want this one. I can hide this one. So acceleration, it might be impact my MPG. So I'll select all this the 5 column to do the analysis. Even sometime the acceleration is not major thing for my analysis, so that I can go ahead only with the four column, and I'll predict my miles per the values. Okay, so this is nothing but what my future selection. So I'll give you a nice sample. So probably like I will prepare some slides to or a simple video I'll share with you guys. If you go with that, it's a bigger process. So we can, that is nothing but a future selection. And model building, you know very well. So you need to split the train and test and train our algorithm using linear regression and class and fit method. Simple method, you can apply that, and you can find out the intercept and slope using from simple function, and compare the actual output value is a predictor value. That is nothing but you can apply the test value to that value, and you can find out the predictor. That is nothing but, let me go to the, yeah, if you weather report, yeah, this is the best example. You can find out. So what is the percentage of the maximum temperature, and you can apply. You can predict the value. Regression that predict of X test. Then automatically you get the prediction. So prediction, putting the value, and you can get the values. This is nothing but the specific step. Okay, and the evaluation. And the evaluation is nothing but you can apply your what is that? This one. So probably you can find out by using a curve, or else we have 3 different methods for linear regression equation. But the root mean square error will directly predicting whether its value is good or not. So that's what actually will come up with the idea of bringing these points or value, how they are related each other. So this specific thing. So based on this value, most of the problem, it is going to be a 0.6, 0.9 between 1 and 0. Okay, so if it is going more than 4, 5, 6 and all, like it's not at all, that's useless. Basically it's based on the data point. Okay, what the data set what we are getting. Okay, that is something but model evaluation. These are the steps, very important. Okay, so just you can make sure that specific with the linear regression, and even for others as well. So most of the 70-80% of the steps going to be very similar. Okay, so you look at it in any other Google or somewhere, definitely see all these steps might be there, but relatively how it's going to be, it's like getting the things done. So it's a bit difficult. So just I what is that, I come up with simple slide. Okay, any questions here? Any questions here? Guys, you guys are there? Hello? Guys, you can speak out. So there's a really challenging, guys, like 2 hours if I continue speaking myself. So we have
No,
almost.
sir.
No,
No
who said
questions.
no? Okay, who said no? Can you say your name? Then you can yeah.
Harini, sir.
Okay, Harini. Right. So you are clear, Harini.
Yes, sir.
Cool. That's very important. And this is actually model performance measures. That's what I mentioned earlier. So to predict like to evaluate your model whether it's a good or bad, by using the R square mean square value, then you can find out that. Don't bother about like the numbers and all. Okay, so it's coming that 0.54 or why it is coming like that. It's based because actually the data, the given data is like that. Okay, so don't bother about that. So like just finally, so getting the data and loading the data and analyzing the what is that the base thing, like what is the size of the file, so what is the size of the given data set, and how many columns are there, and what are the columns are there, and then do you have any null values or not. So if you want to do the changing the null values into the valuable null, then you can do that. And then okay, so to find out like some variant analysis, visually analysis, like how the how all the features are related to each other. So you can use a bivariant, univariant, or multivariant, so you can do all the analysis. So everything's done. So picture representation, everything's done. So feature selection. So after the feature selected, then you can go ahead for splitting the data into two different things using a random method, and then applying that model simple statement regression dot fit. So automatically it will give that data point, started giving the values. Then you have the method to get the intercept and the slope, everything. And then you can find out like what is that, the score, accuracy score. So if you find out this, pull out the score, means automatically it will say the what exactly value. And if you want to evaluate that one, so by using root mean square, it will give the value. That's it, simple. These are the major steps if you go across regression. For others, slightly different, but 80%, 70 to 80% going to be the same. Don't bother about that. Okay, so can we jump into logistics now? Can we jump into logistics now, guys?
Yes, sir. We can move ahead, sir.
Okay, I don't know whether people are like physically they're present or mentally absent, guys. It's a really big challenge for me to, because actually these are very, very important. I don't know like whether you have to show the interest, guys. So it will be really, I can understand it's really dry, but if you understood these concepts, so you can play around the data set and you can find out to so many examples. Okay, right? Because actually I started preparing so many samples here, but since I don't have enough time to run each and everything. Okay, so I have a house prediction, car prediction, and even so many other things. But since we don't have enough time to go through each and every data set to explore those things. But anyway, all the flow is going to be same thing. Like it's not a big deal. Okay. Okay. Anyway, let me go into the logistics. Okay, logistics regression. So logistics regression is a part of the supervised learning under the classification model, and in which it's going to be either the Boolean value, like it's going to be yes or no, male or female, 0 or 1, and it's going to be like, it's just a straightforward and very similar to your linear regression. But in mathematically, if you want to prove this, means it is going to be different steps and all that. But I don't want to bring everything, because if you started doing all R&D on logistics regression, means like it takes almost 2.5 hours to cover the even for logistics, even more on that, because mathematically prove and then what is that, how we can apply on that. Okay, and then evaluation process is a very huge process, but I cut short and what is the minimal thing and understandable way how we want to present. I have prepared the slides and I'm sharing with you. Okay, so it's very simple. Logistics nothing but like what is that, this or that. As I mentioned earlier, regression is going to be the number, and logistics is going to be either two conditions, either true or false. Okay, either do or not. For example, the temperature tomorrow is going to be weather going to be hot or cold. Okay, rainy or no rain. As I mentioned earlier, even for like the sports, some sports person, like say like if Virat, so based on his history till like last test matches or last one day, so he scored almost century means, so we can say he'll score century or not, he'll make century or not. That's it. That's going to be a classification. Then how much he'll score? It's going to be a 150 or 120 or whatever it is. That's going to be a numbers. That's very very important. So what I will do, like I'll just go back to few slides. Just I want to reiterate that one because this is very very important and interesting one. So linear and logistics. I don't know how many of you go through these slides. Okay, so linear is going to be always going to be numerical and is going to be continuous. Logistics actually is going to be a categorical variables. Categorical variables is going to be, for example, the guy actually is from Chennai or Hyderabad. The guy is actually is from India or Europe. The guy is from actually he is a male or female. So mostly it's going to be a categorical variables. Hope you guys remember what is category variables, what is a discrete variables. That is a totally different. Okay, and then objective, calculate the probability of the event. As I mentioned earlier, the probability is nothing but, so Virat can score century or not. Today, tomorrow is going to be a raining or no rain. Okay, something like that. And here the dependency, if you go with the linear regression, is going to be there is a relationship between the dependent variable and independent variable. And here we don't have such a relations, but even though it's very critical to analyze the that what is that your futures, and used to solve the classification problem. And this is for regression problem. What is a classification problem and regression problem, guys? Here, any one of you? So how you can decide the customer if they're giving some statement? So how you can say, hey, the given problem is a regression problem? No, no, this is the problem. Given problem is a classification problem. Any idea?
Is Amelia?
Yeah, yeah. Amelia, are you there?
Yes, sir.
Yeah, man. Please, no other go, man.
Yes, sir. What's the question, sir? I didn't hear. Sorry for that.
Yes, no problem. See, the given
Yes,
problem from the customer
yes, sir.
side, then you have to decide whether it's going to be a regression problem or classification problem. How you can decide that?
Okay,
The
sir.
problem
So,
is given. Problems, yeah. Hmm.
so the problem will be given to us.
Yes, correct. Because
Okay.
you are a
So,
data
sir.
scientist. So we picked up
Yeah.
you
So,
for a
like,
campus entry as a data junior data scientist for our organization. We are asking, there is some problem statement from customer side. Then
okay.
as a project manager, I'm assigning you, we will just find out the whether there is was some business case, find out whether it's a it's going to be a regression problem mode or a classification problem mode. So how you can decide that based on the
So,
business
I think, sir,
case? Yeah.
if it is a classification problem, then we have some classes in that. I think so, like a train or a car, something like that.
Mhm.
But in the regression problem, I think so. The data set we will be having, they will be either to classify just the things like you can say a dog, a cat, a elephant, like those type of regression problems comes in those. If you say for the classification can be like which type of dog, which type of species it is. I think that will come in the classification part, like which type of dog breed it is. That can be come in the classification. Whereas in regression, we can go with the like it is an elephant, lion, or a dog, something like that. We can do.
Mhm. Okay, so I think the most of the answers like going sits with the classification problem, because you are going to find out whether it's a cat or dog itself is going to be a what, um, it's a classification. Again, you are going to find out the breed means you are going deeper into that.
Okay.
Okay,
Oh,
you're going deeper into that. Yeah,
Okay.
anyway, it's a good attempt. Anyway, good attempt. Yeah, some
uh,
anybody else, please.
I
Yeah.
think Sam has responded something. Sam, can you just give your answer? You can just unmute yourself and can you answer it? I think he has told discrete and continuous
Mm.
values as the answer. Sam, can you answer the
Okay.
question?
Sir, classification is continuous values when we do with when we
Yeah.
deal
Give the
with
example.
continuous values.
Yeah. How do you find out that from the
Sir,
given problem statement?
sir, if we consider some values like the price continuously
Uh huh.
changing, that
Uh huh.
like petrol prices, that like
Mm. Mm.
and in regression we do discrete values. The
Uh huh.
curve may be continuous. In classification, it will be discrete values, ones or zeros. Like.
Mm-hmm. Okay. All right. Yeah. Anyway, like a good understanding, guys. I appreciate Upal and this guy also name I forgot. Sham. Yeah. So thanks, guys. So at least you got some terminology around this one. Really good attempt. Okay. So how you can find out whether the given problem statement is a regression or classification? Right. It's a very straightforward answer. What you can say, you want to say is a do this or that, right? So if you're going to be the classification is the given problem, for example, like said what you said, like you said like the price of the petrol is a hike. Okay, the petrol price was given. Then I'm predicting in next 10 days the petrol price going to be high, or is going to be going to be increasing, or it's going to be stable, increasing or not. Okay, decreasing is a different a different thing. I don't want to get into the deeper in that. So if it's going to be increase or not, I have a set of values for petrol for the last 10-15 days till today. Then there was a problem statement. Hey, please analyze whether the petrol price will go high or not. I have some other factors as well in my data set. Then if it is going to be a increase or not, it's going to be the problem statement is clearly predicted, clearly given that analyze the price. So analyze the price for the future prediction. Then you have to ask the customer. That is the second thing. Okay. So if in the problem statement is there given clearly saying that price is going to be high or not, then you have to obviously go with the classification model. Then if they're asking how much price might increase, then you can go for what regression model, as you said, the discrete one. Okay, if it is going to be a categorical one, then you can directly go yes or no. If it's going to be a discrete one, continuous values, then you can go out for regression model. If it doesn't given there, probably you can ask many questions with respect to the given problem statement, saying that hey, the given problem, I'm not sure about like whether you were looking for rise or not. Okay, it's going to increase or not, or else in numbers. And what the proactively what you can do, you can apply the both models and you can say that's different thing, like the higher level. Because as I said earlier, for a simple so for a simple um, for a simple data set, you can apply more than one or two models and you can come up with some solution. Okay, so you can apply for that. That's different issue. But here, if you're discussing with that, we have to go with regression model or else classification of model from the given data set. Sorry, given problem statement. It's clear. That's very important. Okay, so and as people said, like so we want to find out whether the dog, cat, and all means it's like classification again. So straight away is gone to the this one. So if you want to say, okay, if you're going to be given like a number of the cats, number of dogs, kind of numbers, it's totally different. And even the problem statement, if you define going to be predict is going to be a cat or dog itself is a classification. Straight away you can say, correct? It's clear, guys.
Yes, sir.
Cool. So if the problem statement what you were given, cat or dog itself directly is a classification. Don't bother about like the linear regression or any other things. That's different. And again, you are going for it's a breed wise or height wise means it's jumping into the another layer kind of classifier. What is a random classifier, random forest, and what is that decision tree. That's going the take you that will take you to the different route. Okay. Anyway, good try, guys. Thank you. Okay. So this is nothing but the here on. And same way here, as I mentioned, the classification is a binary classification or multi-class classification. Because multi-class classification, binary going to be yes or no, or sometime it could be more than options. For example, person going to vote for Democratic, Republic, or Independent. So, and again, it's going to be a three different classification. So, for example, a person from which state from India. For example, if I'm going to analyze all this mother tongue, where he brought up and all the things, the data point, I can say, yeah, this guy from Tamil Nadu, he's from Andhra Pradesh, he's from Bangalore, he's from Orissa, he's from like West Bengal, he's from Rajasthan. So there's going to be a multiple options. That is nothing but multi-class classification. Okay. That's a very important thing. The binary classification and multi-class classification. And universally, like if you go with like as example, mail spam or non-spam, most of the time is going to be the classic example for logistics going to be always this one. Okay, wherever you go. That's it, simple. And for this one as a curve is going to be like always a sigmoid curve because so either going to be a 0 or going to be a 1. That is nothing but yes or no. So here we are going to find out the so many what is that structures. Then we have to find out to select the maximum likelihood. So how many things are matching this curve to make this curve? Then we have to choose that as a our final curve. How we are doing in our R square linear regression, right? We are finding the proper line. The similar way here you have to make sure that the line should be a sigmoid. Okay, again I'm telling like a mathematical things. It's a really deeper. So I don't want to go into that details. Otherwise, we never ending process. Will keep on taking the classes all the Sundays, Saturdays, and Sundays. Okay. So let me go into some use cases, beautiful use cases. See, for example, to predict the student will get the admission or not based on the given CGP. Okay. So what I can do, like I have some threshold. If you get like more than 8, then I can say we can get that value. Okay, if it is less than 8, obviously there is no possibilities of getting admission. So that I can predict that value. But I don't confuse here again linear, so I'll go with the logistics. So if it is going to be more than 8, I can get the admission. So that's what actually I'm thinking here. And the same way, to predict the emails, if it is going to be a spam or no spam, based on the email IDs, what the email IDs I'm giving the list, then I need to compare with that. If the email ID is not like matching with that, then I can decide the specific email is a spam. If not, then I can make sure that is a non-spam email. Same way, to predict the rain or no rain. So what I will used to do, I'll make like temperature, humidity, and I can find out the value like the rain or not. That's what actually the earlier things, right? The weather prediction, the maximum temperature, minimum temperature, all those calculations you can predict them. There is a possibilities of getting the rain or not. So those things. And same way for financial purpose, so we can like predict whether the applicant based on the applicant the history, and so we can decide whether we can give the what is that the loan approval or not, because actually the how much loan we're giving, that is different issue. But if you want to decide we able to give that specific answer yes or no, so we can go ahead with that. So mostly the system, like what it will do, automatically it will do the prediction. For example, I don't know how many of you tried this one. So if you have just in ICICI or HDFC and all, there is a loan predictor or loan approval kind of stuff. So what they will do, you can log in, and you can, if you're going to be like already have account in specific the bank, then you have to provide your details, and you have to provide your credit card details, all the detail, and you can apply for loan. Once you click on the specific button, automatically it will predict like how much loan you are able to apply. Okay, that's very important. Correct? That's very, very important. So the same way, it will directly say you're eligible for loan or not. That is nothing but actually you can internally they used to decide the machine learning algorithm, go and check with all the what is that, the your history, then you will predict the values. And the same way for engineering field, for example, if you have a bigger plant, okay, it has a huge the components in the manufacturing industry. So each components, um, uh, it's asset management. So for example, if it is going to be asset management, so in the asset management system, all the valves, pipes, and what are the components inside your plant, everything is recorded in your asset management. I'm not sure, probably I can give a best example. In your college, you could see there is a number for fan, bench, and a desk, cupboard, and even for a door, and so many things. Correct. So that is something but your asset management. So they have a details in the college repository. So they used to say there are 1,500 bench are there. It's going to be like when it has been arrived, and do you need any maintenance for the same. So all the information they'll be put up in that repository. I don't know like how did you notice that or not. The same way for the engineering, the plant manufacturing plant, for each and every components has been recorded in asset management tool. And the asset management tool, we will take the data point, and we can find out the ages of the voltage for the specific component. We want to diagnose whether we want to replace the asset or not. Okay, for example, the specific component, it's almost more than 5 years, we shouldn't use that, we want to replace that. Then immediately the system will recommendation saying that, hey, these are the components that we need to replace immediately. Then once it's come to that, the specific supervisor or the floor manager or shop manager for approval, he's supposed to give the approval. Then that will be going to the procurement team. The team will generate the place the order, get the new components, and immediately once it's back to the team, they will go and replace the old one, and they will update the system saying that these are the components has been replaced with the new one. Then the new item going to be in the asset management tool, so that they can track the performance of the specific the component. They can go ahead on that. So those kind of stuff like we can apply for the engineering field. The same way for the medical, like for the what is that? So the continuously the what is it? The patient's health. I think earlier 10 to 15 years back and all, there is no record. For example, recently if you're going for any normal clinic, so what they will do, they will create a file for you. Correct. So they'll create a file for you, and automatically they'll start recording all your the health issues, like if you're going for headache or fever or any other pain, things like automatically they'll record everything. Then after some time, is there any major things that happen for specific patient, they'll go and refer that data point, what are all the specific patient undergone during the history, and they will analyze that, they'll predict that, oh, because of this reason actually continuously this guy is having a headache, so that might be what any other issues are. Then they can give a treatment appropriately. So olden days we don't have those things, like even if 100 times you're going hospital, so 101 time if you're going, like they don't have any evidence what exactly what the problem. And for even those are people doing the continuous treatment, under the treatment they have a complete bigger file. Okay, and that actually all their what is that, the testing, blood test, urine test, checkup, heart checkup, etc., etc. What are the document available? They'll put it in file. They'll record that. So for the future reference, they'll use that. So if you're feeding all the data into the system will predict the specific the users, the specific patient's health, how it is. It is good or bad. Forget about the internal details. Okay, if the bad or good. If you want to give if you're okay, I'm planning to give some operation for specific patient, then I'll do the analysis. Then the severity of these specific diseases is very high, means I need go for recommendation for what is that for operation, or like you can go ahead with the any meditation. So they give the options. So similar way, there are so many use cases across in our industry.